Right, let's go back to this again. Sorry about that. The bloke next to me, who lives next door to me, was drilling. So if you hear that, it's not me letting go wind. So we got up to here. So we can write our equation. So now we've got our equation here. We can use it to work out these first bits here. Okay, so the distance the ball falls in 3 seconds. Well, that means t is 3. Okay, so 5 times 9 is 45 meters. Okay, and then calculate the time the ball takes to fall 605 meters. Well, that means d is 605. Okay, and then I need to find t squared. Okay, and so t is 11, because 605 divided by 5 is 121. And that's direct proportion, but I would always set up this to start off with. Okay, in fact, sometimes you're actually asked to write an equation connecting the two variables d and t. Okay, so let's have a look at inverse proportion. So what we should say is, so direct proportion, that it means as one increases, the other one increases. Okay, inverse proportion is as one increases, the other one decreases. Okay, so here T says is proportional to the power, so the time it takes for water to boil is inversely proportional to P. So the more power I put in, the less time it takes, which makes sense. And then we have our initial condition here, or condition here, and then we find the value of K and then set up and work these bits out here like we did before. But it says inversely proportional. So when it says inversely, what inversely means is 1 over x. Okay, because as x gets bigger, this value gets smaller, and so that's what inversely means. So it's, in this case, t is inversely proportional to p, so 1 over p, and then can take 1 over p and multiply it by k. Okay, and that gives me an equation instead of it just being proportional, because now I've got my proportional constant. I can put in my initial values of 360 and 1,400, and that gives k as 504,000. Okay, then I can use that value in an equation. Okay, so that gives me t is equal to 504,000 over 900, because here k is 504,000, and our first question, p is 900, so that gives t is 560 seconds, and then I can do that. Okay, so this time we know t, and we want to find p, and so p is equal to 504,000 divided by 200, which is 2,520 watts. Okay, and we can check. So this wattage is bigger than this wattage. Okay, and so this wattage is less than this wattage, and so we've got a longer time, which you would expect. This time is less than this, so you would expect a bigger wattage, and we've got that. So that's a good check to see how we're getting on, if we're in the right ballpark with the answer. Okay, so I'll send you some questions like this. These are only 3 of the questions, but I've got a sheet that's got these questions on and a bit more, so I'm not going to go over these here, but you can have a go. I'll send you the sheet with it. Okay, what you also need to be able to do from this chapter is to, like we said, recognise graphs. So you should all recognise that anything with x squared, so this could have a coefficient here, I mean it could be, it's just ax squared plus bx plus c, will look like this, will look like a U shape. It's a parabola, it's symmetrical, and it's like a U shape, like that. Okay, minus x squared, on the other hand, will look like an N shape. Okay, and you have to recognise these shapes. So for instance, if I wanted x squared plus 7, I know it would go like that, but I would know that x squared plus 7 would give me a graph similar to that, but obviously this point here is 7, okay, because when x equals 0, y is 7, and so it just moves the graph up. But you have to recognise what these shapes are. You don't have to be specific, because we've looked at sketching before, but you just have to recognise what the shapes are. And so we're going to have a look at some other shapes here. Now this is a cubic graph, so a cubic graph will not look like that. I don't know what happened there. It won't have this part here. A minus x cube graph will look something like that. Okay, be very careful that when you're drawing these you don't tail it round like that, because it's not going back like that and you will lose marks for the drawing. Okay, so that's a big no-no. That don't do that. If you know this, I always would suggest draw in pencil because you can rub it out. So for instance, this blue one, you would rub this bit out and then just draw it there. So 1 over x graph looks like this. Okay. Again, be careful that you don't tail it back up, or it goes up, or it comes away. Interestingly enough here, 1 over x squared graph looks similar, but because it's squared, well, I haven't put squared there, 1 over x squared graph looks like that. Okay, a minus 1 over x will have a 1 here and then 1 down here. 2 to the x looks like that, an exponential graph this is known as. It's the fastest rising graph. Oh my god, I can't even speak. So 3 to the x is like this. Okay, in fact, any value a to the x goes to this point here, which is 1. Okay, because when x is 0, 2 to the power of 0 is 1, 3 to the power of 0 is 1. Okay, and so you have to recognize this graph. So a typical question would be, here's 4 graphs, here's 6 equations, which equation belongs to which graph? And they could be linear, and you just have to use facts like, where's it crossing the axes? So when x is 0, where's my value? What type of graph is it? Is it negative x squared cubed, or positive x cubed, or negative x squared? Yeah, just those sorts of things. If this was minus 2 to the x, then the graph would go like that. Like that. Okay, last slide. So here this is using a graph and using the exponential graph. Here we have a graph, and it says here that after a year, which is year 1, population is 120. Okay, so that gives us after 1 year, so a point on there that is 120, and year 2 is 144. So that's year 2, 144, and that gives us a 2-year point there, which is, this is 120, this is 144. Okay, and it says that we can use this equation to get these values, where t is my x coordinate and p is my y coordinate. So I know that from this equation, 120 is equal to ab to the power of 1, and 144 is ab squared. So what I can do is I can divide these two equations, like solving simultaneous equations where you can add or subtract. You can also multiply and divide them. So if I divide this one here by this one here, I get 144 over 120, which is just that divided by that, and I get this divided by that. No, I haven't put the 1 here because it's not necessary, because b to the power of 1 is just b. And so if I divide, I get 144 divided by 20, but the a's cancel. So the a's cancel, this squared term cancels with this, and it just leaves me with b. So it enables me to find b. 144 divided by 120 is B. So what this means for our diagram is that every year we're increasing by 1.2, which is a 20% increase, which means that this is increasing by 20% each year. And so once I've found B, I can find A, because if this is 1.2, I can find A. 120 divided by 1.2 is 100. And so that gives me A. And that means when this is 1, so at year 0, okay, this is this point here where it crosses the y-intercept, okay, or where the p-intercept in this case. So this is initially how many people were in the village, okay, and we're increasing by 20% each year, and these are the values after 1 and 2 year, okay. Now it says here when will it exceed 500. Now you can just try by trial and error, just by multiplying by 1.2 each year and seeing when you get over 500. But there is a way you can use this, which you don't really do until you get to A level, but I'm going to show you anyway, is by using the log button on your calculator. So if you have this written, this is the equation. We want to exceed 500 here. So now P is 500, we've got 1.2t and 100 here. So 1.2t is 5. Now if I do log of both sides, okay, this value here using a log law, I can take this t away from it and put it there. Okay, and so that's just the log law. You don't have to know why at the moment, but you can just use it that way, which means that t is log 5 divided by log 1.2. So you can just type that into your calculator, and in this case it gives you 8.83. Okay, which means that the number of years it will exceed will be after the 9th year, so 9 years. Okay. Hopefully you'll be able to do the questions. I do know proportion questions and inverse proportion questions students normally find quite tough, so do reach out to me if there's any problems with any of the questions in that chapter A9.